Yeah, but 7 said she's a lot more calm.
Hi, Mary and Daphne. Jason Mastowski is here, so we're gonna do our best to record this. Okay? Just kidding. Right now we're doing work on the board, so you can't see it.
Wait, then what was the point of starting?
Why do you start it now then?
She's trying to get Jason to.
It is given that TY. Wait, why?
No, I heard the high.
I'm waiting for you guys. I can write it.
Yo, you guys
I'll do them quick for you, so you're not just sitting here.
I don't know where I'm getting all this energy from, but 5 hours.
Oh, they do the second one too. Yes, please.
Where did Tyler go? Tyler, sure, go ahead.
No.
Check your work with Ellie's. How'd you do?
I hate using Z.
Okay, Paige.
Wow, he can hear you, Paige.
It looks like a 2 when I write it.
Yeah, that's why I put a thing through it.
I don't really like anything other than.
I used to teach at an international school, and kids used to write their ones like this. Do you know how confusing that is?
Wait, how do they write them?
They would write it.
They're like what?
Never mind. I'm on freeze. I'm giving the answers to the other people at home. I'll show you at the end.
Here it is.
Miss Walchek, you're a mathematician. How much horsepower is in one horse?
I have no idea. Does somebody know about cars? In here?
It's more than 1 horsepower.
I'm pretty sure. Yeah.
I don't know about this topic, but I would guess to say that a horsepower like is the power of 1 horse.
It's not.
No,
It's not.
it's not. What? Then what does it even mean?
There we go.
I thought horsepower was like the power of horses, and then it was transferred to cars when the Olympics were done.
Yeah, like that's what I thought it is. But like, why would like 1 unit of horsepower not be equivalent to like 1 horse's power, right?
No.
Horses are
You think so?
freak.
But the other one has more words.
Yeah, horses taste kind of strange.
Wow, though. Wow,
I
though.
never understood it. My horse is black.
Or I got it wrong.
No, you had it right.
All right, so here's what I got. All right, how did we do? Yes. Yes. Let me see the first one. Oh, Ellie, you write so small. Yeah, good job. All right, sweet. So, how did everybody do?
My cook.
Okay. If you finished 1 and 2, bravo. We're going to come back to 1 and 2 because 3 and 4 are a little trickier. I want to show you 2 methods of solving integrals before we go back to 3 and 4. So if you did 1 and 2, good job. If you didn't, we're going to come back and do it in a little bit, okay? So go ahead and go to page. Don't say it. No. Page 10. And we're going to talk about the first tool. U substitution.
No.
No. All right, don't freak out. It's not that hard. Think about it like this, okay?
Whenever you
So-
say something that works, always say it.
Thank you, Pat Weiser. Pat Weiser, can you say it a little louder?
Reverse chain.
It's
U
the
sub-
reverse chain rule, right?
Oh!
It's the reverse chain rule. So,
Boom!
if you see a function And then you also see the inner function derivative present in that integral. Follow the train of thought, right? If I let u be the clear inner function here, you can account for the fact that there's this extra little x cubed and this extra little dx here with u substitution. I'll show you how it works, okay? Yes! It's the opposite of the chain rule, pretty
Is
much.
there also a short?
So,
Is there also an opposite shortcut?
yeah, you're,
You just add one and divide the whole thing with that.
no, you can't, yeah. So, like, this one looks like if you were taking its derivative, you would use the product rule, right? So if you ever see the product of two functions, that's your indicator. Ding, ding, ding. I'm going to need to use u substitution because I don't know how to do that yet, okay? So let's identify the clear inner function. What is the clear inner function here?
X4 plus 1.
Good. Don't overthink it. So we would say let u equal x to the fourth plus 1. So now the u substitution works as the reverse chain rule because we now have to take the derivative of the u, okay? So now we would have 4x cubed dx. Don't forget about the dx when you're doing the du, okay? Don't forget about this. Check it out. We're gonna put it all in. We're gonna put it all in, okay?
Wait, we had a derivative.
You have to find the derivative of u because when you do the chain rule, right, you take the inside, right?
Yeah, I just thought we didn't take the integral because it's integral.
No, here, look, you'll see it. Just look where everything goes, okay? So, is there a 4x cubed next to the integrand?
Next to what?
Like, is there a 4x cubed in there? What's just in there? Okay, so remember how before when we were taking integrals, you can just pull that constant out? You're going to pull the constant out. Just hold that thought for 1 second. I'm sure it's good, though. Actually, it's probably good, but
If we're putting the dx on the end of the derivative of a, isn't it technically not the derivative anymore?
hold that thought. That's a great, I like that you're suspicious. It's good to be suspicious. Wait until everything comes all together and then see if you can answer your own question, maybe. Okay? So we don't have this 4 in here, right? We don't have this 4 in here. How do we take the 4 out?
You can take the constant out.
Yeah, let's divide both sides by 4, right? So now I have 1/4 du is equal to x cubed dx. What you're trying to do right now is like account for all of these pieces in the original integral, okay? So I'm going to change my color here. Hold on. Do I see this in the integral?
Yeah.
Do I see this in the integral?
Yeah.
Okay. So then hold on, let me plug my computer in really fast. Okay. So if I have a 1/4 out front, right? I've added this guy, he's new. And I rewrite this new integral where u is x to the 4th plus 1. Do I see an x to the 4th plus 1 in the original? I do. He's right here. What is left? I have a square root. Under the square root should be a u. du encompasses all of the blue pieces. I now have an integral written in u's. I'm going to integrate with respect to u. And I'm going to be able to just do it real quick. Yeah. Okay, stop. Yes, I will stop and process. Applause for processing.
What?
Just wait. We're gonna take the integral and then we're gonna do it again. All right.
So we
So
take the integral of the thing of u right now?
we're gonna integrate u to the 1/2. Yep. Try to do it. Try to work ahead a little bit if you can. That might help you process it. But we're gonna stop for a second and everyone just take a look at everything. You're using u substitution as a tool to integrate something that you don't know how to integrate yet. Yes.
So you want to get, like, is the point dividing the 4 to get the x to the third, like, by itself, or do you want to match whatever comes from?
It's to get the x to the 3rd by itself because an x to the 3rd is in the integral.
So you
The
wanna match
4
it?
is not. So you gotta match it. Yep. Because you both of those things are right. Yes, we're doing both. Yep. Any other questions? You had, so to answer your questions, you had to change the differential to du because you had to encompass the dx. Because now you're changing the variable with which you're integrating.
Wait, so where did the x and third go?
What?
Where did the x and third go? Like, where would you put that?
We rewrote it. Du is all three, is all the both
Oh.
of these
Just take this
things.
out.
Du speaks for him and him. You speaks for him. Nobody spoke for him, so he's still there.
Oh, got it. Okay.
Good questions, you guys. All right, now let's do it. It's like once you get it, you got it.
There's no way the microphone will pick up. Probably 20 hours in the next 2 days. We're going to set 3 to 10 today and then 12 to 12 tomorrow.
All right, now careful. This is the last part, okay? You got to answer the question the way it was asked, right? Did it ask you for u's or did it ask you for integration with respect to x? X, right? So let's take that u, right? And I'm going to pull out a u and put in an x to the 4th plus 1 to the 3 over 2 plus c. And that's your answer.
That's free. That's literally free.
So we got rid of the
Literal Costco sample.
Where'd the d go?
Sorry.
That's just how you write the integral.
Where did the du
Oh.
go? When you,
It's
take
just-
the, when you take the integral, the du goes away.
doesn't-
He's the differential that comes on by working backwards.
Wait, so what happened with the 1/4?
He was just like out front, and then I had to like divide by 3 over 2, essentially multiplying by 2/3, and then I just reduced it.
Oh. I get it.
Yep. Can I rewrite this as, I don't like it, but I get it. Can I rewrite this as
It's Walter. Who gets this clip?
what? I'm sending it to just your parents. That's all.
Okay.
Okay.
Oh.
No.
That's double prank. That's double prank. Okay, but I think
Andy Mostowski.
Is that your dad's name?
Nate Smith. All right.
Are those two dads? Two dads that we're working with here?
Yerp.
Can I rewrite this like this?
Yes.
Can I? Is this okay too? Yeah.
If you're
But I
feeling
just
it,
want us to just like
Nate Smith.
think about how we can rewrite stuff, okay?
What's your mom's name?
Okay. So now I want you to fight through the following 4 examples, okay? I'm going to do them on the board. Stick with me until you feel like you can peel off, and then you try doing them on your own, okay? People who are currently with me, so I know who to ask questions as I work through it. Raise your hand. Who's currently with me? Who's already peeling off? Okay, all right. So,
Miss Ballcheck, I have a question.
What?
Do people have you ever met somebody who's not like a teenager that's named Ava?
not a teenager that's
Like,
named
have you ever
Ava.
met like somebody's mom that's named Ava?
Yeah. Wait,
Really?
one of my friends married a girl named Ava. So she's like my age. She's like 30.
Well, yeah, my mom. I've been like,
Well, like none of my mom's friends that I know of are named.
I don't know anybody that's like named Ava that's
Like,
not
10
our
years
generation.
older than you. Do you know anyone 10 years older than you?
Or like even a grandparent, an elderly named Ava. Like I've never that doesn't exist.
An elderly? Don't call them an elderly.
Why?
Like
Not
think
an
about this.
elderly.
Like my mom's name
I
is
said a
Amy, but
grandparent.
like
Is a
I don't
grand-
know a single person
Is
in
a
this school that's
grandparent not an
named Amy.
elderly?
You know what I'm saying?
Your mom's name is Amy.
Yeah.
Amy. Do I know an Amy?
I know it.
I don't-
My neighbor's name is
Multiply?
Amy.
I don't know. What?
You have to multiply this one?
Hold, please.
Dividing?
Let's
All
see.
right, let's
What
get
is the
back on
clear?
task
What is
here.
the clear U? What is the clear U right here?
3x squared plus 2x.
Hold on.
Oh wait, no.
Oh my gosh, no
I
way.
didn't- never
We
mind, I
want
didn't
U
reverse.
to be the
I
inner.
didn't-
So think about it as if we have like e to the something. This guy is inside the argument of e's exponent, right?
Oh.
Therefore, when I take his derivative, I want to be looking for it.
Why do we have
Something
to
that I
go from like
multiply
the
again.
simplest stuff to like the hardest stuff? Like why can't we just like practice on simpler problems?
Because you're smart and you got it. So now,
because then the derivative is
The derivative's in there. He's in there. You just got to look for it. Okay. So then now I'm going to find du. Okay, do you see this now? Where is he? Find him. This guy, this guy. Where is you? Find him. Where is you? All right. So now what are you rewriting with your u substitution? The integral of e to the u.
Whatever the first stuff.
Look for it, right? du encompasses all the pink. U encompasses all the blue. I've now just rewrote it in an equivalent yet simpler form. Isn't it? Isn't it?
So is the derivative of the u always going to equal another thing?
It's always.
You just took the derivative over a u and it's just the same as that.
If you take the derivative, these only work if the derivative is present in the integral. There's like a special type of things that these work with, you know?
Is it because you divide du and 3x squared plus 2x times dx? Divide both sides by dx. So you get du over dx. And then that dx cancels out.
Yeah. Good job, Tyler. Cool. All right, so now if I wanted to take the integral of e to the u, it would just be what? E to the u plus c, and then rewrite him. E to the u is x cubed plus x squared plus c. How do you think you guys can check your answer? What can you do?
Deleted it.
Oh my god, there's no way I'm gonna be able to teach this in half of a set, 7 sets. Okay. All right, see you guys in a few.
See you in a jiffy.